Okay, ji, Bismillahirrahmanirrahim. Now, let's discuss this example. Okay, so we are traveling from our goal, which is A, to D, as mentioned before. And the system, the process of finding the optimal path from A to D is as follows. So we start off by our starting position, which is A. In A, we can see that A is directly connected to AB, AC, and AF. So as you can see here, AB, AC, and AF, we have three paths to originate from A. We will find the fitness function for all three paths. As mentioned before, the fitness function is the actual distance, G of n, plus the heuristic value, which is the estimate distance to our goal, which is D. So as for example, A to B leads to 13, and a further of estimated 100 positions or 100 points will lead us to D. So the fitness value will be 13 plus 100, 113. So a further estimated D is 100. So 113 is the total fitness value of this path, AB. Same thing goes for AC. The actual distance from A to C is 45, whereas from C to D is an estimate value of 51. So 45 plus 51, 96. And same is the case with AF, is 20 plus 89. So we got AF 20 and F will result in a further of 89, so 109. So out of these three paths, I will have to investigate all of them to try to find the shortest path. But we'll start with the shortest path at the moment. So right now, AC is the shortest path. So we'll start here. So when I reach AC, where I reach C, I can go only from C, I can go to G. So now I have created a new path, which is ACG. So to calculate the G of n of ACG, I have now the actual values of A to C is 45 and C to G is 25. So that's 70. However, from G, a further of 30, a distance of 30, an estimated distance of 30 will result in 100 from ACG. ACG 100. So the fitness value of ACG. So I'll repeat it again. If I have reached ACG, A to C is 45, C to G is 25, which is 70, and G will require another 30 points to reach the destination. Estimated is 30s to reach the destination D. So 7 plus 30 is 100. So the fitness value for ACG is 100. Now, similarly, I'll now investigate AF. AF is from AF, I can go from AFC and AFE, two paths, AFC and AFE. So AFC is like this and AFE is like this. So the distance from A to F is 20 and F to C is 30, so 50. And from C onwards, it will take another 51 to reach D, estimated. So 50 plus 51, 101. Similarly, AFE is 20 plus 100 and another 15, estimated 15 points will be needed to reach our destination D. So the fitness value for AFE is 120 plus 15, 135. Similarly, let's investigate AB. From AB, I've got only one option. I go from AB to C. So AB, that's 63. How? 13 plus 50. ABC 13 plus another 50 to C is 63, and C will require another 51 points estimated to reach D. So 63 plus 51, 114. Okay, so now I have explored AC, AF, and FP, and I have resulted in these four new paths. Let's start with the smallest of these four. Smallest, since I've explored these, now let's try to explore these four paths. And we'll start with the shortest one of these. The shortest one, of course, looks like 100. So I will start with ACG. From ACG, I can go to ACGE and ACGD. So from ACGE, A to C is 45, C to G is 2570, and G to E is 10. So that's 80. And from E, I require another 15 to reach my estimated, I require an estimated value 15 to reach D. So ACGE fitness value will be 80 plus 15, 95. Whereas ACGD results in A to C, C to G 70, plus D 40, 110, and D, since it's my goal, it will require 0 since I'm at my goal. So I will add a heuristic value 0 to it, 110. So now I've reached a goal. As you can see that I have reached a goal, and I have this cost. I have a path that results in my traveling from A to D at this cost. So that means any unexplored, further unexplored path that does that already is greater than 110 and does not yet lead to my goal can be cancelled out. So that means I can now ignore ABC because it's not near the goal, and it's already of greater value than my current goal. Similarly, I can ignore AFE. No need to explore here either because its value is currently greater than the path that I've just discovered to my goal. So these two paths don't need any further investigation. Now, amongst the unexplored paths, I've got ACGE and AFC, but this is one still. I have this path is still unexplored. So let's explore this path. So of the three nodes, this is the unexplored path. So let's see what AFC has. AFC, in fact, we can ignore this as well. No, we continue with this. AFC, no. AFC, let's see, it's lesser than my current goal, yes. And okay, let's see if it reduces the value. Anyway, so AFC, from AFC, I can go to AFCG. I have only one option. So A to F 20, F to C 30, and C to G 75. And G requires another 30 estimated to reach D. So 75 plus 30 is 105. And secondly, I have this path over here, ACG. Okay, now I've got two new paths. I've explored AFC. Now let's discover ACGE versus AFCG. Now, amongst these two paths, this one should be explored first because it is shorter. ACGE should be explored first. Now, ACGE will only allow another node to be connected, which is D. So ACGE, A to C 45, C to G 70, G to E 80, E to D 95. So 95. Now, since I've reached the destination, my goal, the heuristic value will be 0. 95 plus 0, 95. Always the heuristic value when you have reached the destination will remain 0. So now the total cost of this path is 95. Now, as you can see here, I have just discovered a path which is shorter, even shorter than my previous goal path. So that's why this will no longer be considered. This no longer needs any further exploration. And I have now reached my optimum solution of ACGED 95. And there's no other unexplored. We have explored AFC, so we can cancel this out. See, we have just explored AFC. We can cancel this out. We have explored ACG, sorry. We can cancel this out. And there are no more unexplored paths. We have started with AF. We have seen AC. We have also seen AB. We have all no unexplored path, and at the end we are left with this path ACGET, which results in the shortest path as compared with the previous path that lead to goal. It is obviously shorter, so this will be the optimal solution. And this is how you find the optimal solution or optimal shortest distance from the source A to the destination D using A star algorithm.